Data analytics, as much as it's a buzzing field, it's not something that was born like yesterday or 5 years ago. Data analysis has been there for time immemorial, starting from when people discovered that the Earth was not flat to the positions of the stars and planets. People have been using some sort of data analysis, analyzing data in some form or the other. Right. So this became more and more scientific over time and more sophisticated over time. Once the IT revolution happened and a lot of data was getting collected, right? When I mean data, it's all the documents, it's all your numbers, everything that could be recorded was being recorded. Then people started asking, can I draw value out of this data? Right? That's when data analytics as a name, as a stream, as a mainstream discipline was born, and now it's become quite a mainstay of organizations to stay competitive. So one of my research projects as part of my college degree was, how can I use mathematics to model cities? Right? So how do cities function? How do transportation networks function? Right? How does economic activity happen? Like, where do people build houses? Where do people go to work for? Right? How can I translate all of this into some math equations? Right? So this was what I studied. And then I extrapolated this to saying, how can the same math be used for not just cities but also other areas like business? Right? So that's what I do today, applications of math, statistics, computer science to help companies, to help businesses analyze their data and do better at what they already do. You will see today politicians use data analytics, right? So who should I target? What messaging should I give people? Right? What are people most interested in? That's just an example. But you take mainstream business, you take retail chains, consumer packaged goods, high tech, insurance, financial services. You name it. Any organization that is able to collect data, which is able to record their business in an electronic form, which is data, will benefit from data analysis. The company question saying, are we giving out these discounts in a very ad hoc manner? Shouldn't there be a method in which we do this? Right? Then what we did, we analyzed all the data. What's the data here? Who are the customer? What products were they purchasing? What was the price of the product? What was the discount being given, etc. After all the analysis, we realized that there were several places where a discount was not needed. Right? So the company was losing money in giving a discount when it's actually not needed. On the flip side, there was also several examples where they should have given a discount. Because they did not give a discount, the customer just walked away, would not buy the product. Right? So what we came up was with a simple framework saying, hey, these are the customers, when they purchase this kind of products, you would want to give them a discount. Right? Or in these circumstances, in these areas, you don't want to give a discount. Right? So this increased their sales and profitability significantly. When you go to a supermarket and you are purchasing something, what are the things that are driven by data analytics? You'll be surprised to know that, right? When you walk in, how many aisles should be there? What should be the spacing between the aisles? Right? What products should be displayed on the aisles? In the front row, in the second row, in the third row. Right? If you're looking at Britannia 50/50, should there be 5 packets lined up or should there be just 2? All of these, people have analyzed data there to say, if I have more, like how much should I price it? Will it indeed sell more? Or does it really not matter? Right? These are all decisions which have been made by data. First of all, common sense to spot some patterns and trends in the data, right? So, given a set of numbers, you should be able to spot basic trends there, right? So now, most of us can do that when five numbers are written on a piece of paper. But what it takes to the next step is when the size of the data is larger. What if there are like thousands of data points there, right? So what it takes is a good understanding of math, like basic math, which most of us do at a school or a college level. Ability to program, right? Which is now at this scale, when you're working with so much data, you cannot put pen on paper and do all the analysis. Right? So you should be able to read all this data into a computer, into your program that you're writing, and conduct the analysis within a programming language. Right? So two basic things there, in addition to common sense, of course, is understanding of mathematics and ability to program. So these would be the two key skills. So today, for someone who's been in a quantitative discipline or a technical discipline like an engineering, is very well primed to be in this position. You need to just make that shift, which is learn a few new tricks of the trade, like using certain programming languages to be able to analyze data and such. Bridge that gap, and you're very well ready to take a plunge into this new area. But in terms of tools and technologies, absolutely yes. There are several things, some of which would be very useful. Starting with for basic data analysis, right? Comfortable with Microsoft Excel. I can turn around the data whichever way, do my products and sums and shares and your pie charts, some patterns, etc. That's a basic to have. But take it to the next level, right? The most common programming languages for data analysis today are R and Python. Right? So if you're someone who wants to get in, one or both of these will be very handy to pick up. Who's a data scientist? A data scientist is very similar to a data analyst. It's a new terminology, new algorithms, new technologies have come in, so the terminology also changed. But a data scientist and a data analyst today, the terms are used completely interchangeably, but that's quite different from a business analyst. If you want to analyze your credit card statement, right, then you would just copy your credit card statement into an Excel file, look at how much am I spending on various categories, or per month how much am I spending, etc. All these things. But imagine you have to do this for everyone in the country or all the customers of the credit card. Then the size is so big that you can no longer use a simple Excel file to do this. Right? So this is big data for you. So the size of the data, the variety of data, for example, it's no longer numbers, maybe there could be images, videos, the speed at which the data is coming. Right? It's no longer static data. Maybe for every second there are like more and more gigabytes of data coming in. Right? So for example, you take astronomy, like you're taking recordings of galaxies far away. That's big data for you. What are we trying to solve here? Just like when we try to solve any problem, it's the same with the analytics problem as well. What is it that we're trying to solve? Once you've identified that, then you go saying, is there data that can help me solve this problem? Say for example, you want to understand why are my customers leaving? So that's a problem statement. So then the next step is to say, do I have data which can help me answer this? So you define the problem, now you collected the data. Data collection could mean collecting new data or looking at existing sources of data, but bringing it all together into one common platform that you can analyze. So the next step is a data exploration. So So you want to understand at a high level what are the relationships between the data, in the data, what are the high level patterns I'm seeing, etc. The next step becomes using the right algorithms to specifically address the problem that you have at hand. So it could be a forecasting algorithm, it could be a fraud detection algorithm, it could be an image recognition algorithm. So that becomes step 3 in the process, where you've used the right algorithms to come up with the right insight. And step 4 is, once you have the insight, how does the business actually use the insight to change their process to make it better? So we play it step by step again. Step 1, you define the business problem and clearly articulate what is it that you're trying to solve. Step 2 is you've got the right data in place and try to understand high-level relationships in the data. Step 3 is use the right algorithm, forecasting or fraud detection, whatever. Step 4 finally is how do you use these insights from these algorithms to help the actual business process. I think it was about 10 years ago, Harvard Business Review named data science the sexiest job of the century. Right? So I don't know about that, but it indeed is very, very interesting because you are able to address problems that were earlier unaddressed. You did not know that such problems could be solved, and suddenly you have this tool of analysis, these technologies, these algorithms in your hands, and you're able to solve a variety of problems using that. Right? So, for someone interested to be around numbers, to see how numbers can be related to real life phenomena, it's an absolutely wonderful field to be. But if you're not someone who's too comfortable with numbers, then probably not the right field. An international degree is not mandatory, not absolutely needed. It helps to have a degree, but it's not mandatory. What is needed is, or what would really help you kickstart your career or advance your career in this field is you're updated on what the latest this field has to offer, what are the latest developments. So there are really world-class material out there, which has been put up online by the best researchers, best professors of this world on platforms such as Udacity and Coursera that you can access to and get the gist of what an international degree would otherwise give you. It's three important skills for us. The first one, comfort with numbers. Given some numbers, you should be able to do some quick calculations and make sense out of it. Spot some trends. Number 2, ability to program. So, given some logic, you should be able to write a piece of code, a program to convert that logic into a computer program. Number 3, the most important thing is the attitude to learn. This is a fast evolving field. The algorithms of today will be left behind, or the algorithms of tomorrow will be far better than or far superior to what we have today. Technologies are changing. 10 years down the line, what data analysts will be working on will be quite different from what they're working on today. So one has to keep learning continuously. So that's an important attitude we look for in people. Looking at this video, the field of analytics is a very exciting one and which is going to grow significantly. So if you are contemplating is this the right thing for me or not, I would urge you to take a serious look at this, because this is going to be quite big in the near future and a lot of opportunities. It's not just about one specific business vertical, it's going to be across all companies. And everyone's will be using this very soon. So big opportunity is out there and something you can all benefit from. So I would really encourage you to look more seriously into this opportunity. Thank you so much and all the best.